Hello and welcome to the first video for 8.5 complex numbers. So we're going to talk in this section about complex numbers and revisit a lot of the same things we have in the past with the last four sections. So first let's talk about what on earth is a complex number. The term complex does not apply to hard. Okay, so we're not talking the difficult numbers. That's not really what we're talking about here. We are talking about a combination of two types of numbers. First off, there are things called real numbers. Just a reminder here. The real numbers are the numbers that you've been growing up with your entire life. So they're your classic counting numbers, 1, 2, 3, 4, ... But they're also the negatives. Oops, pardon me. And your 1/2 and your 2/3, your fractions, right? And then also things like your non-terminating decimals, 3.1415926 ... aka pi. Even it's also the ones that don't have a name but go on forever. Basically, a real number is something you can write on the page, okay? It is something that has an identity. It is something that follows all the rules of math. The real numbers have to follow the rules of math. Now, there is one number that no matter how hard we try, simply just does not follow the rules of math. It is the imaginary number. Okay, and there is actually only one of them. If you really look hard at this, there's one imaginary number. It is the square root of -1. And you're thinking, Miss K, -1's a number. Absolutely. The square root of -1, though, is not a number. When we're dealing with radicals in this entire chapter, we've been running into this issue of does not exist. This number does not exist, right? We have, if you think way back when, to things like, it may even have been like here. Yeah, so way back when in section 3, we had this problem where we were trying to take the square root of -100 or the square root of -10,000, and those things are not possible. You cannot multiply something by itself once and get a negative number. That's just not how the real numbers work. And so, ooh, that's a new button. And so we have to say this is an imaginary number. Here's the problem, though. We can't just say it doesn't exist, because when you have numbers that multiply back, you can actually make this number work. There's several proofs that show that this number has to exist, that it has to be this thing that exists in the universe, or the rest of the math breaks down. Now, it's a fairly complex conversation, and I could take time to show you, but basically it has to exist. Okay, if you want more information on that, feel free to reach out, join math club, things like that. But right now, let's just say this number has to exist. Since it does, we will give it a name. We're not going to create a new symbol for it, right? We're not going to add suddenly, a new one of the numbers. We're just going to give it I for the imaginary number. Okay, this is the imaginary number. There's really only one of them, because this is the only thing that has to exist, but then also doesn't at the same time. You can take this imaginary number and combine it with real numbers and actually solve things like that one we just saw. So the square root of a -100, we could actually solve this now if we take out the I part. So if I rewrite this as -1 times 100, and we'll revisit this again in just a moment, but this is where you find out there's only one. Then I've got that one imaginary number and a 10, a positive 10 now, and we get 10I as the square root of -100. It still doesn't exist. That is still not a real number. It's still not able to be plotted on a number graph. I can't put 10I on a number line, but I can write it now. Okay, so there's really only one imaginary number, but you can adapt it to any of the real numbers and create basically a whole nother number set. Now, this is the idea behind a complex number. A complex number has two parts to it. We're going to talk a lot more about that in just a second. If you're wondering, complex numbers combined real and not real numbers. Some examples include 2 plus 3i. Here's your real part and your imaginary part. Other numbers include 6i. We'd probably just lump that into the non-real complex numbers, aka the imaginary numbers. And then you get more adaptations there. Next up, we're going to look at how to simplify these a little bit, kind of do some more with that -100, and I will see you in the next video.